Dear students, we are going to see Unit 5 line integrals in vector calculus. So now see the definition of line integrals now. So let C be a curve. We are taking a curve first. What is the curve? It is C be a curve in R cube. So what is R cube? R cube is equal to R cross R is R cube. So it is in a three-dimensional space we have to define this curve. So where the entries are all real numbers. So between 0 to 1 you can find infinite numbers. Since it is real, you can find infinite numbers between 0 to 1. Every entry is a real number in this three-dimensional space. Described by a continuous vector valued function. So what is C? C is described by a continuous vector valued function. It is described by a vector valued function. So you know vector valued function is valued function R vector of t. So R vector of t is nothing but x of t, I is y of t, j is z of t, k vector. So these are all unit vectors. So I, j, k are unit vectors. So C is defined like this. R vector is nothing but C. So now we have to take a function. Let f be the function. It is also a continuous function. So you need not know about continuous for integrals. When you study a continuous, you will see in detail. So let f be a function. F vector is equal to f1i, f2j, f3k, right? So where f1 is a function of x, y, z, and f2 is a function of x, y, z, and f3 is also a function of x, y, z. So f vector is defined as f1i plus f2j plus f3k. So f vector is also described in same region with the curve C. So now see the definition of the line integral. The line integral is defined as defined by integral over C f vector dot d vector is the line integral. It is defined as integral over a to b. So what is a to b? Here we have a continuous vector value function in terms of variable t, where the t ranges from a to b. Value of t ranges from a to b. So here we are taking the integral over a to b. f1 of x of t, comma y of t, comma z of t is a function of variable t and x of x, y, z. So x of t, y of t, z of t is a function of t, x, y, z. f1 is a function of x, y, z. So you have to write f1 of x of t, y of t, z of t into x dash of t plus f2 of x of t, y of t, comma z of t into y dash of t plus f3 of x of t, comma y of t, comma z of t into z dash of t into dt. It's the expansion for this integral. This integral is the line integral. So f1 x dash of t, f2 y dash of t, f3 z dash of t into dt is the expansion for this line integral. Integral over c f vector dot dr vector is equal to integral over a to b f1 x dash of t, f2 y dash of t, f3 z dash of t into dt is the definition of the line integral. So we have seen the definition of the line integral. Now we can see work done by a force. Work done by a force definition. So nothing but work done by a force is given by the force is taken as f vector. Here the force is taken as f vector. So work done by the force is given as the line integral over c f vector dot dr vector. So work done by the force f vector is the line integral. Integral over c f vector dot dr vector. If they ask for work done, you have to find integral over c f vector dot dr vector. So using this line integral definition, we are going to solve a problem now. we are going to solve a problem. Let's see the first problem. In this problem, they have given evaluate integral over c f vector dot dr vector. That is, we have to find the integration of f vector dot dr vector, where f vector is equal to x squared plus y squared I vector plus x squared minus y squared j vector is given. So f vector is given and the curve is given as y is equal to x squared. So curve joining the points is 0 to 0, a to b. So here we have to take the curve first. So given curve C is y is equal to x squared. So for the given curve, we have to write parametric equation first. So parametric equation is nothing but, so we have to write simple form of this curve. So when we plotting a graph, we have to understand the graph easily without any complications, so that we are taking in terms of parameter. So parameter is nothing but t. So here we are going to substitute t instead of y equal to t. So instead of y, we are going to substitute t. So what is x? So x becomes so when we take y is equal to t, so here y is equal to t, x squared become t. So therefore x become root t. So it is more complicated. So we are avoiding this and taking x is equal to t. So take x is equal to t. Don't choose y as t. So take x is equal to t. If you take x is equal to t, then y become t squared. So y, since we have y is equal to x squared, so from this you will get y is equal to t squared. So if you take x is equal to t, you will get y is equal to t squared. So we are going to find the integral now. Integral over c f vector dot dr vector we are going to find out. So integral over c f vector dot dr vector is equal to, so integral over a to b f1 x dash of t plus f2 y dash of t plus f3 z dash of t into dt. So it is the integral. So given f vector is equal to x squared plus y squared I vector plus x squared minus y squared j vector. So in this, what is f1? So it is f1 and f2 is x squared minus y squared. So f1 is x squared plus y squared, f2 is x squared minus y squared. So we have to substitute x as t and y as t squared in terms of f vector. So f vector f1 is equal to x squared plus y squared implies, what is x? X is t squared. So t squared plus y is, so x is t, so x squared becomes t squared and y is t squared, so y squared becomes t power 4. So similarly, you have to find f2 in terms of parametric equation. So it is t, when you substitute t, it will become a parametric equation. So x squared minus y squared. So x squared is t squared minus y squared is t power 4. So now substitute this in this integral. So we have found f1 and f2. In this f vector there is no f3. So now we have to find x dash of t. So what is x? X we have taken as t and y is t squared. So x dash of t is 1 and y dash of t is 2t. So differentiate, you will get 1. If you differentiate with respect to t, you will get 1. With respect to t, if you differentiate y, you will get 2t. So you have to substitute here. So integral over c f vector dot dr vector is equal to integral over a to b. Now you have to come for the limits, so a to b. So how we have to take this a and b? So it is a curve joining 0 to 0, 0 and 1, 1. So therefore t lies between 0 to 1. So the value of t lies between 0 to 1. So here integral over 0 to 1 f1 x dash of t. So what is f1 we have here? T squared plus t power 4 into x dash of t. So what is x dash of t? It is 1 into 1 plus f2 y dash of t. So f2 is t square minus t power 4 into y dash of t. Y dash of t is 2t. So 2t into dt. So now we have to integrate and give the answer. So it is equal to, so t square, integration of t square is t square with respect to dt. So first we simplify this and then we will integrate. So t square plus t power 4 running to the term is the same thing, plus 2t into t square is 2t cube, and minus t power 4 into 2t is minus 2t power 5 into dt. So dt is common for all this term. Now you can integrate. So integration of t squared is t cube by 3. Integration of t power 4 is t power 5 by 5, and 2t cube is 2 into t power 4 by 5 minus 2 into t power 6 by 6. So and then apply the limits and tell me the answer. I will check your answers. You send me the answers. I am expecting your answers. So this is the